Welcome to Deriving the Heat Equation Solution, Part B. So recall in Part A, we assumed that u of xt was a capital X of x times a capital T of t. And we essentially had broken the problem down to two problems. Our first problem was that x double prime plus lambda x was equal to 0 with boundary conditions, x of 0 equaling x of L equaling 0. And our second problem was that y prime plus a squared lambda, sorry, not y prime, t prime plus a squared lambda t was equal to 0, and we had no initial conditions or boundary conditions on this part. So we are going to go ahead and solve these two problems separately. So first off, solving for x, we are looking at x double prime plus lambda x equals 0, with x of 0 equaling x of L equaling 0. Recall from chapter 11, this has solutions or has eigenvalues. Lambda sub n equaling n pi over L squared. And eigenfunctions phi sub n of x equaling sine of n pi over Lx. So I'm actually going to change these. Instead of phi sub n, we'll now write these as a capital X sub n. Solving for t, we are looking at t prime plus a squared lambda t is equal to 0. This is our most basic homogeneous first order linear equation. We get then that t of t should be equal to e to the negative a squared lambda t. And then, of course, it could be a constant of this, right? So t of t equals c e to the negative a squared lambda t. So since we are only interested in our lambda sub n's, so since we are only interested in lambda sub n equaling n pi over L squared, all other lambda just have trivial solution x. We will go ahead and take t sub n of t to be e to the negative, tossing that a squared inside of the other squared we have, n pi a, or a n pi, over L squared t, all in that exponent. So putting our x and t back together, again, recall that we assumed that u of xt was equal to capital X of x times capital T of t. And so we will have, we'll set u sub n of xt to be capital X sub n of x times capital T sub n of t. And we get that our u sub n of xt is e to the negative n pi a, or a n pi, over L squared t times sine of n pi over L x. So these solutions to the boundary conditions will be our building block for the other solution. So note, each u sub n satisfies our first partial with respect to t is equal to a squared times the second partial with respect to x, and also satisfies the boundary conditions, u of 0t equaling u of lt, all equaling 0. So it only remains to satisfy the initial condition. U of x0 equaling f of x. And we will do this in the next video. So we have our building blocks, our u sub n's. In the next video, we will put them together and figure out exactly what we need to meet the initial condition as well.